Welcome to Diamond Solutions for Mathematics. Here we are discussing 12th standard differential applications of differentials, that is rate of change of quantities. Here is a question. The area of an expanding rectangle is increasing at the rate of 48 centimeters squared per second. The length of the rectangle is always equal to the square of the breadth. At what rate the length is increasing at the instant when the breadth is 4.5 centimeter. Applications of differentials, and we have to analyze the question first. At what rate the length is increasing at an instant when the breadth is 4.5 centimeter. That means breadth is constant here. According to this constant breadth, what is the rate of length increase, rate of increase of length of the rectangle? That is the market. Therefore, we can consider length and breadth to be the main role here. That is, let L and B be respectively the length and breadth of the rectangle at time t. Time t is parameter for length and breadth. Here, length equals, therefore L equals B squared. And the length of the rectangle is always equal to the square of the breadth. Always the length is square of the breadth. According to increase or decrease, the length will be always equal to the square of the breadth. Therefore, L equals B squared here. And also I am letting the area, let area be the area of the rectangle at time t. Therefore, A equals length into breadth, L into B for a rectangle. L equals B squared. Why? Because length is always square of breadth in this question. Therefore, instead of L, I am putting B squared into B. That is B cubed. Therefore, area is increasing at the rate of 48 centimeters squared per second. That is given here. 48 centimeters squared per second. Therefore, dA by dt, that means area's differential coefficient is dA by dt. Parameter t, area is dA by dt equals plus 48. Why? Because the area is increasing at the rate of 48 centimeters squared per second. Therefore, dA by dt equals plus 48. That is d by dt of b cube. Why? Because we already defined area equals b cube. Why? Because L into b, L is square of breadth. Therefore, instead of L, I am putting b squared into breadth b. Therefore, b squared into b cube. I concluded the area to be b cube. Therefore, area is increasing at the rate of 48 centimeters squared per second, means dA by dt equals plus 48. That means dA by dt of b cube equals plus 48. That is, differential of b cube is 3b squared. And time is implicit here. Therefore, 3b squared dB by dt. Implicit, the differential coefficient stick along with it. Therefore, 3b squared dB by dt equals 48. Therefore, dB by dt equals 3b squared comes here as 48 by 3b squared dB by dt. That is, dB by dt equals, when we simplify this 48 by 3b squared, it comes to 16 by b squared, the simplest form of dB by dt. That is, rate of change of length with respect to t equals dl by dt. Rate of change of length with respect to t is dl by dt. That is, d by dt of b cube. We already defined L to be b cube. Area is b cube. Therefore, b squared is length. L equals b squared. Therefore, dl by dt means d by dt of instead of L, b squared equals 2b, b squared. The differential of b squared is 2b and db by dt is implicit, b. Therefore, length is L, but we are not differentiating L, but length, the score of length is differentiating. Therefore, b squared is differentiating as 2b, but it is implicit, therefore db by dt. That is 2b db by dt equals b into db by dt equals 2b into 16 by b squared. 2b db by dt, that is 2b into 16 by b squared equals 32 by b. Area is positive. When b equals 4.5 centimeter, the rate of increase of length equals 32 by 4.5. That is 7.11 centimeters per second. That is the rate of increase of length, which is defined as the final answer of the question.